All right, we have the mic on. Good evening, everybody. I thank you for being here at this time, the last session of the day. My name is Johannes Kebeck, and I'm really grateful. You had a long and exciting day today and yesterday, and I realize of the burden that is upon my shoulders. I'm the last man between you and the attendee party, so I better have a lot of good news for you, and I hope I can deliver on that part as well. So, last year at Build, Ricky Brundett, he is a colleague and program manager on my team, introduced you to our Bing Maps version 8 control. It was a complete rewrite of our control for the web applications, and that was the focus of his presentation and the development patterns around that. Since then, every other week we had a story to tell about new features, about data updates that we brought to the platform, re-engineering that we have done in the back end. We have improved the data pipeline. We have launched, as of today, 30 million square kilometers of new imagery for this year. We have had a vast amount of new things that we launched in this time frame. And so I want to start today with a couple of new features that we have already released in the version 8 experimental branch. So version 8 introduced a branching system, experimental, where we iterate very quickly with almost weekly updates and bug fixes and new features. Then we have the release channel, where we have a very stable version that is recommended for production environments. And then we have a frozen channel that is less frequently updated and allows you to have the -1 version of the release essentially also available. So two of the new features that I introduced to you today are related to the user experience in the version 8 control. And then there's another one that will be launched shortly around developer experience and making more with less code. And then I will take you on a virtual tour around the world and introduce you to 4 new APIs with code names that reach from South Africa over the Middle East to Asia, and then back to Egypt. And I will introduce you into some of the very exciting new APIs, and I feel honored that I am the one who can represent the hard work of the teams that is behind that here to do today. So with that, let's have a look at some of the improvements that we have in our platform. In the version 8 control, shortly after the launch, we introduced templates that are optimized for data visualization. Dark canvas, grayscale, and high contrast styles that you can easily switch in the base map. Today, we reached the point where we have a fully customizable map style. You can decide what element of the map you want to show and which one you want to hide. You can fully customize the color or the visibility of every element in the map. And the idea behind that is that you can bring in your colors that reflect and align more with the web design that you have chosen, or it can be the corporate brand that looks and feels more like your sports team or the colors of the company that you have chosen. Let me go and give you a quick demonstration of how that could look like. So on the left-hand side, I'm opening up now a window that goes into our version 8 control. On the right-hand side, I put up Visual Studio and hide unnecessary stuff. So here we're going to see a JSON object that looks at the different elements of the map style. So you see country region is one of the parameters, and then in hexadecimal color codes we can describe the visibility and the color of each of these components. You see here, at the moment, we have country names and other labels that are currently visible. If I wanted to make this invisible, I can essentially go and switch the visibility to false, and reload the map, and they are gone. If I want to go and change the color of the background of the map into something that is more greenish, then I can do that as well. I go down here to the land color and exchange this code into something else, and you will see immediately these background colors for the country change as well. Let's reverse what I have done here, because it is not really all that pretty. Let me save the map style and come back. So what you have seen here on the right-hand side is a JSON object, and is exactly the same style and the same JSON object that you can use for our web control as well as for the Windows 10 map control. So it's the same styling pattern, the same styling template that is behind that, and what works on the web will equally work on the web application as well. Now, the same applies if I want to overlay certain points, or if I want to put this heat map that you have seen before, then we can reflect this with a certain color scheme as well. Let's get the tweets about our Seahawks as a heat map, if it then allows to talk to me. Well, that is apparently not the case. Okay, but let me tell you a little bit more about what happened here on the styles. If we look at the maps itself, those are generated by an on-demand service. So the base map is rendered at the runtime. It's then pulled into the map control, and each of the templates that you put in there will be rendered at runtime, cached in the content delivery network, and then pulled in with the same styling template that you have in there. So once you have loaded the map and it is rendered on demand, all subsequent requests will also take advantage of the performance of the content delivery network. Let's have another look at the announcement number 2. And move on to our oblique aerial images. One of you guys already asked me before, what we call bird's eye is oblique aerial images. They are taken in a 45-degree angle with north, south, east, and west-facing direction. And that was a feature that we had in the version 7 control, the predecessor of the current version of the control. But when we went out with the version 8 control, it was initially not there. There were a few things that we had to sort out on the metadata service and so on. So initially we launched it without these bird's eye images. But now that we are approaching the end of life of the version 7 control, we heard your feedback loud and clear, and we brought in these oblique aerial images in the version 8 control as well. And as of this week, they are in the experimental branch. Not just are they in there, but we also brought them in with a refresh of the imagery and an additional zoom level. So if we look on the left-hand side, the old version of the imagery and the new version of the imagery, you see that you can have more level of detail as you zoom in there. And this is a higher resolution image that we processed for large parts of the stock that we have available on oblique aerial images and make available today. Speaking of imagery refreshes, I mentioned before 30 million square kilometer of aerial and satellite images have already been updated in this calendar year, which is just 5 months old. Today, we are happy to release another batch of updates. All of North Africa and Eastern Europe has been completely refreshed with the imagery as well. Let's move on to, here's a little bit of the code, how we implement the bird's eye imagery version 2. So you see here it's the same way how we loaded it in version 7. We provide a map type ID that can be road or aerial with labels, and it can be bird's eye. And for version 2, we just put the V2 behind it so that we load these new images in the map control. So let's move on to number 3. We have a demo of that available, but it's not wrapped as a module yet in our map control. But it's a feature that I think from the developer perspective is quite interesting. It's a GeoXML module that allows you to just simply drag and drop geospatial data formats in an XML format onto the maps canvas and then pass it out into the points, lines, and polygons that are described in this XML format. So this supports GPX, GeoRSS, KML, and also the zipped version KMZ. So you can drag and drop the KMZ file onto the map canvas. The module will unzip it and render it right away. Let's have a quick look at how that can look like. We're back into my map canvas. We close this one. And then this is Bird's Eye version 2, our GeoXML module here. I drag that to the left-hand side. And on the right-hand side, I open up my file explorer, and there's a few KMZ files. Let me take one that describes the school district areas and just drag it and drop it into the map canvas. So you see here on the top right corner a few statistics. That was a 4 megabyte file that we have in here. It was unzipped, it was rendered. There's 22 polygons with more than 114,000 points. And the rendering time is less than 200 milliseconds. That's pretty decent. And the implementation of that is only a couple of lines of codes to load these forms of XML data, GeoXML data, into the map. Not only that, we can also go and export the data and wrap it up and download it in a very similar way. So in this case, I have here a file that describes the layout of a church. If I want to create an XML format, there you go. So it reads directly through the data and it creates me the XML format in whatever style I would like to have. So that was a few hints on the user experience and the GeoXML module. And now let's move away from the user experience and go to this virtual tour around the world, starting in South Africa. And let me introduce you to Project Johannesburg for the first time. We're introducing an API that implements special requirements for vehicles that exceed standard sizes or have certain speed limits that are unusual or have requirements for the legal transportation of goods. So why is that necessary? Think about something like this here. This is a bridge that is near the Arboretum in Seattle. And if you look closely on this arc, there's quite a few hit marks there. They call it the guillotine. And why is that so? Well, there's quite a few of these vans, trucks, caravans, RVs that hit this bridge because they are unaware of the low height of this bridge. And there's, of course, other requirements. If you have these larger vehicles, maybe longer, they can't take a tight turn. They may be heavier, too heavy for a bridge. They may be transporting hazardous material. And this is what Project Johannesburg, our truck routing API, and truck in this case is really in its widest sense. It covers also recreational vehicles, caravans, and so on. This is what we address in this API. Speed limits are specific for these trucks as well. So where you may be able to drive for 60 miles or 70 miles, the truck usually has a lower speed limit than that. We have a preference. Trucks, large trucks in particular, dislike crosswinds, right? So they are very easily affected by strong crosswinds. They don't like steep gradients. And they are exposed to grounding risks because of the long wheel stand if you drive over a railroad crossing, and we are addressing this through that API as well. So I'm going to show you a few examples, but here is a sample API call. We're having start point, end point, multiple points in between, up to 25 points in total. And then we can provide additional parameters that describe your vehicle. how high it is, how long it is, if it is a semi-truck, what the azimuth of a turn is, if it has transporting flammable cargo, if it has a permit for chemical transportation, and so on. So all this is something that we take into consideration, and I want to give you a few of the demos of how that could look like. So here we're back on my demo machine, and I load a number of scenarios in here. I have a start point and an end point, and in this case I define the height of this vehicle as 5 meters. So if I now call the routing API, I have actually called the routing API twice. I have it called once for a standard vehicle, and that is represented here in the red line. And then I have called it for the truck that has the height of 5 meters, and that is represented through the green line. Now, why is that? Why is this route different? So our street side images that we have also in the version 8 control embedded can give us a hint on what happened here. We're looking at this low bridge with a clearance of 12 feet and 9 inches, and that truck of that size cannot fit through that bridge, and therefore it has to take the detour. Let's take another example. So here we are looking at a truck that has a certain length. If I calculate my route again, the vehicle can take a fairly tight turn here at this road. The truck has to take the long way around. Why is that? Our street side images give us a hint here as well. If we look a little bit closer, you see that this is a fairly tight turn, and the large truck will not be able to make this turn at all. So we take the left turn here and drive the long way around. Let's look at example number 3 and calculate our routes. The car is driving directly from west to east and up this road here, the West Bravo Street, and the truck is making this weird turn and then eventually coming up to the same point where the straight line was from the car route. Why may that be? If we look at our street side imagery, we get a hint on what the problem might be. You see it already there in the distance. It's inclining quite a bit, and it will actually be worse. There's a 19-degree incline, and we said that our truck, with the load that it has, doesn't want to take more than 10, so we're essentially driving around this area. Now, number 4, and the last one for truck routing, that looks awkward. We have a straight line where the car can drive here. That's in Pennsylvania, and we're looking at a route that goes through the Liberty Tunnel, and the truck that we have identified here, he is transporting a flammable cargo. So we provide it as the URL parameter here, F. That can be explosive. There can be a comma-separated list of spelled out names or abbreviations that describe what the hazardous material is that the truck has. Flammable cargo, radioactive material, chemicals that you are not allowed to drive through water protection areas, and so on. And with the flammable cargo, you're not allowed to drive in this Liberty Tunnel, so we take the long way around here. So that was a quick one on the truck routing. I will come back to our demos in a moment. And meanwhile, switch back to the slides. From South Africa, oh, by the way, somebody asked me this before. Is this, my arrogance or vanity that they called it Johannesburg? No, it is not. My name is Johannes, but we called it Project Johannesburg because when we made up these code names, I was on a business trip to South Africa, and that was the first thing that came to my mind. I'm not that vain. So next project is called Abu Dhabi, and it's called Abu Dhabi because on the trip to South Africa, my stopover was in the Emirates. And Abu Dhabi is a project that picks up on this more logistical topic that we have with the truck routing API and Project Johannesburg. If you have to make a lot of trips in one day, then there is a number of considerations that you want to make. How do you optimize these trips? You want to find out what is the best time window to go from and visit individual customers. The whole thing about scheduling is a very interesting one, and how you charge for the mileage that you have to visit these customers might be another one. The time that you spend on that trip. And for many of these tasks that I just described, distance matrices are a good tool to work around. So Project Abu Dhabi implements a distance matrix, but one that has an interesting twist. It doesn't give you just a matrix with origins and destinations and the travel times or distances for a given time of day, but it gives you a complete histogram of the travel times that you might have for the next 7 days in 50 minutes intervals. So it will give you an overview about when the peak traffic hours are and when it is more quiet. When is the best time to travel from Seattle to visit your customer in Bothell? Probably not at 9 o'clock, that would be quite obvious to you, but maybe there is even a day of week variance that we have to consider. And this is something that we solve with Project Abu Dhabi, so the travel time histogram that you see here, but we can also work on that and optimize the trips. So if you run, for example, business on pest control, right, and 5 customers call in with different pests that they have to get rid of. The first one was this giant rat that you have to get out of his backyard, right? And there is somebody who has a bobcat that you have to take care of, and somebody with yellow jackets under the roof, right? So a number of these calls, and then the day begins. You have your folks that are driving out there, and rather than having them drive back and forth, you want to have the optimum route that is the least effort and the least cost and time on the road spent. So this is the other aspect that we want to address with this Distance Matrix API and Project Abu Dhabi. Let me go and have a look at some of these implementations. And there we go. So first let's have a look at the histogram. And I want to say I calculate a distance matrix for a number of locations. Let's take these 5 here. I do a request that goes back to the API, and it gives me now the distance matrix and the histogram for the next 7 days and in 15 minutes intervals. So what you can see is it's fairly quiet on the weekend, then the traffic picks up again. We have the peak morning and evening traffic hours. Fairly normal traffic during the day and fairly quiet during the night, but your customers don't want you to show up at that time either. Now, clearly you can see when the best times of the day are, and you can split this out. We can find any time window in there from an hour, half an hour, or these 7 days that I just described, and we give you for each cell of the distance matrix the histogram as you see that here, as a number of values that you can work with. So I talked about how can we optimize these trips if we have multiple customers to visit. So this is where the solution for the traveling salesman problem comes in. And here I have a number of stops that I want to solve. I call our Project Abu Dhabi API, and then essentially we apply a genetic algorithm that optimizes the sequence of stops in here. So if you look at this map, the original entry sequence that we had was 0, then 1, then back to 2, then 3. That was the number, the order in which the calls came in, but obviously it's not the most efficient way if I go back and forth, and then we back forth again, and then up here. So our Project Abu Dhabi reordered the sequence of the stops from 0 first, then I take this route up to 3, then I go back to number 1, I go down to number 4, and then back to my start then number 2, and then the start location. So that is the optimum order that we have, and it essentially saves us in effort almost 50% of travel time. Travel time is what we're measuring here for this trip that we have in front of us. Let's move on and have a look at oh yeah, maybe a short look at the API parameters. So we have here the optimization of, we want to have either time or distance if we want to spend less time or have the shortest distance. We can provide the mode of transportation if we want to walk, drive, or use public transportation. We have a sequence of origins and destinations, and we can also bring the start time and the end time of these trips into that calculation as well. Now, from Abu Dhabi, we move on to Nanjing. Nanjing is the former capital of China, and it also happens to be the place where my parents-in-law live. And we have in Project Nanjing the extension of what I showed you here. So we are optimizing the travel time, we are optimizing the travel distance. Maybe we also want to optimize the search for points of interest or asset based on the travel time or distance. So if you think about you're searching a property, as an example, you are in the market for a new house. You work here in Seattle, and you don't want to commute for more than 45 minutes. What is the area that you can cover in 45 minutes if you decide that at 9 a.m. in the morning you want to reach the office? So we need to look at the traffic, we need to look at the road network, and we need to define the area that you can cover in that time window. Now another thing is, if you extend about that one, your wife might be working or your partner might be working in Everett, and he also or she doesn't want to commute more than 45 minutes. Now we have two of these requirements that we want to look at. So what is the intersection of these drive time polygons that we describe with these isochrones, and we want to search what is inside those? How can we solve a problem like that? That is what Project Nanjing is supposed to do. And let's have a quick look at some of those. So we support the travel time and distance in Nanjing, so we can say how many miles on a road network, how much time you can walk or drive with public transport or with your car. And it also includes predictive traffic, so what is the traffic on Mondays, 9 o'clock, 10 o'clock, 11 o'clock, and so on. If we look at this API, it's really simple to use, a REST service call as well. We provide the start point, we provide the route mode that we have, driving, walking, or public transport. And then we have a time or distance that we want to provide. And then we can have the start time for the trip or the end time of the trip when we want to finish it. Let me give you an idea on how that could look like. So here we are looking at Project Nanjing, and let's say we're looking at Seattle. My problem is I don't want to commute for more than 30 minutes, and I want to be driving. Now let's find what this area is that I can cover in this time frame. So we come up with a polygon that goes fairly far up. It even crosses some of these toll bridges that we have. By the way, we can also avoid certain areas in that algorithm. So if I say I don't want to go through toll bridges or ferries, the polygon would look largely different here. Now, this is the optimum case for us, right? This is essentially a case that describes how I could be driving if there were no traffic at all, and if I could always hit the speed limit that were available. That's certainly not the case if I want to arrive at 9 o'clock in the morning. So if I redraw this polygon now, and I say my arrival time or departure time would be 9 a.m., and I can provide specific dates with that one as well, and I create my isochrone right now, then you see that it's a very different area, right? So there is at least 10 miles to the north and quite a bit to the east and west that I can't cover in this area. So that was my place of work and my time that I want to arrive. And let's set this as a target area for the search of my points of interest, in this case houses. So my wife wants to work in Everett, and if I do the same thing for her, also with the same time, then we create a new polygon, goes up there, and obviously there's north of Everett a few locations that are not really interesting for me because it is quite bad for my commute time. I set this as a second target area, and then I can use a function in the Bing Maps version 8 control that allows me to intersect where these two polygons that I just described have overlap. And it identifies these two areas, there's only these two, on the east side and on the west side of Lake Washington, where either one of us doesn't need to commute more than 30 minutes to work. So if I go and increase the time for my wife, she will probably be fairly angry with me. But maybe we get a little bit more of time out and overlapping areas out here. Then we can create our second target area and do a new intersection. And you see here with this new polygon, there's a few places here on the side of Bellevue that would fall into that polygon that would suit both of us. Me more than my wife. All right. So, having a look back at our projects. Where have we been? We were in South Africa, we were in the United Arabian Emirates, and then we went to China, and there's one more left, and that is Project Wollongong. Does anybody of you know where Wollongong is? Where is it? It is in Australia, yes. About 100 odd kilometers southwest of Sydney. Very nice place. And it happens to be the place where I met my wife. So Wollongong is a project that builds on these isochrones. So we have now identified, my wife and I, an area, or two areas in this case, where properties are available that meet our requirements for commute time. The next thing that we want to look at is what else matters to us, right? Restaurants that might be there, bars, museums, other forms of entertainment, cinemas, for example. And we can essentially go through a number of these places and give it a score, how close it is to the requirements that we have. And that is what we want to do with Project Wollongong. We want to give a score for the proximity to points of interests that matter most to us. The proximity based on travel time or travel distance again. I don't want to go for more than half an hour to the nearest bar, because otherwise I might be sober again when I get home. So these sort of things are some of the considerations that we may want to make with the scoring APIs, and there's points of interest categories that we support. Arts and entertainments, attractions, museums, restaurants, bars, and so on. That is only a sub-list of what all we support in Project Wollongong. Medical centers, childcare services, and so on. So, again, all this is implemented as a REST API. You provide a start point, you provide a route mode, you can provide a list, a comma-separated list of categories, IDs that are well documented, and then we can look at the maximum time or distance that we want to walk. And again, we could put something in like a start time for traffic as well. So if I want to reach certain places in the morning, the childcare service on the way to work, then the start time for the trip might be relevant for that as well. So, having a look at Project Wollongong. Here we go. So, if I load scenario number 1, Bellevue is one of the options that we have considered. Obviously, you can provide any full address in here, which would be more realistic if we have settled on a house. And I want to get a scoring out of this, right? So you see here essentially We have 10 places that are in the category art and entertainment. There's attractions like museums and parks. There's a lot of restaurants that I can reach within 15 minutes of walk in Bellevue. Plenty of bars, childcare services, only 8, but how many do you need? Right? So, and ultimately, I made it very simple, and I give this location now because I basically decided they are of equal importance to me, so I'm not weighting any of these categories. I make it simple, and I give Bellevue and this location in Bellevue a score of 121. So if I move on and try the same with Redmond, then we see here we reach a score of 98. Childcare services are even more in Redmond, right? Not really surprising. There's a lot of busy professionals that work for Microsoft and other companies, right? So there's a good business for childcare services in this town, and a good choice. Restaurants are less, bars are okay, not too bad. So that might be an option for me as well. So if we look at Sammamish, the other side of Lake Sammamish, that doesn't look too good. So bars, there is only 1. And I don't want to have the impression or create the impression that I'm a regular in there, so that might not be the good idea. On the other side, there is plenty of childcare services as well. So many people live here in Sammamish near the lake and commute then to the other side, Bellevue, Redmond, and so on. So not surprising that there are so many of these services. And then number 4, let's have a look at Issaquah. And Issaquah gets a score of 73. Very nice parks there. You can do kayaking, you can do hiking a lot there. Quite nice restaurants as well. There's a railroad museum, right? So all that together brings Issaquah a point 73. And if that were be of equal weight, the priorities that I would set for home hunting, then I could say I would focus myself now on Bellevue, right? And then maybe Redmond next, and I don't want to go to the east side of the lake for further house hunting. So that was a quick run through our world tour from projects. Project Johannesburg in South Africa is our solution for truck routing or routing for heavy vehicles. We have Project Abu Dhabi for distance matrix with histograms and traveling salesman solutions. We have Project Nanjing for isochrones and time-based search. And then we have Project Wollongong for the scoring of the attractiveness of a location based on proximity to points of interest that matter most to you. All of those are available right away, as of today, in the Cognitive Services Labs. You can sign up there for a free trial. We hope that you sign up for a free trial. You check it out and provide us feedback. Each of these projects has a user voice channel, and we don't think it's perfect. We think it's pretty good, but we don't think it's perfect, and we would like to get your feedback and see what else, what other we should implement in these APIs, and maybe what the next step should be to provide more value and differentiate these APIs that help you beyond the normal mapping and routing in a solution that helps you solve your business problems, your business needs that you have. So that is 4 code names. We had 3 new projects in the map control. That leaves 1. So the last one is Project Hurghada. Has anybody of you been in Hurghada? It's a fantastic place for diving. So I made my diving instructor there, and I did a number of beautiful reef dives and wreck dives from there, boat dives that got me out to the reefs in front in the Red Sea there. It's fantastic. If you ever get a chance to visit Egypt, you have to go diving in Hurghada or Sharm el-Sheikh. So, Project Hurghada, what is that about? Project Hurghada is also an API, but it goes beyond that. It is a quick start solution that we want to launch to make it easy and simple for you to have a team tracker ready, a solution that allows you to find out about the whereabouts of your colleagues, of your drivers. Think about onto that person who was running this pest control business, right? He has 5 people that are driving out to the customers and taking care of their problems. So he wants to know where they are. A new customer is calling in, and we need to address and redirect one of the guys that is taking on this new case that we have. Maybe we want to know for home care services where the nurses are, how many miles they have been driven, how many trips they have had in the last week, right? So that we pay them accordingly based on not just for the hours they have done with the patient, but also for the hours that they have spent on the road. So the simple tracking solution that we have put into place is by no means something that we would suggest for large dispatching companies or large delivery and parcel delivery companies. This is more for the small and medium businesses that have a certain amount, 50, 60, 70 or less vehicles that are out there, and they want to know where are my assets, my employees, how much time did they spend on the road. I want to be notified when they reach a certain location at the customer or back in the office or at the warehouse where they are making a delivery. I want to be in full control of this application as well. So it needs to be mine. So the idea behind that was we create a service that you can take and deploy in your own Azure subscription. So if you are a Microsoft Azure customer, and you go to projecthogada.azurewebsites.net, then you will be prompted to log in with your account and deploy this solution directly into your Azure subscription. Let's have a look at how that can look like. So Project Hogada, this is projecthogada.azurewebsites.net, and I want to take a new project name here. Let's say we call it the attendee party, because that's where we're going next. And I picked the Azure subscription. I have access with my account to multiple Azure subscriptions. I pick one of them. I can pick a region, and I can pick the owner email, that is in this case mine, to which it is supposed to be deployed. Now, if I click on deployment, then you see there's a status update. It tells me something, and it's complaining about something. So we call it something different, 2017 5/11, and we try it again. Something went wrong. That's not good. Maybe Azure tells us a little bit about what happened. So I can sign into my Azure subscription. And then we can see not much happened here. Nothing to see yet. I will try, my network connection changed, so I need to refresh this part. I log in again. And then we say, we call it the attendee party. We go into this Azure subscription and we click on deploy again. Then we can see what happens here in Azure itself. It will spin up a resource group, and as you see here, it will create an Azure web application. That is where we host the Angular 2 application, powered application for the user experience. We host a number of web services that receive the tracks. We have an Azure SQL database and a storage account for diagnostic information, and then there's a number of Azure functions that do some interesting things like trip detection. So when we log in into my Azure subscription, you see the first services are already here, and then when I click on deployment, we see what the entire process of this deployment into the subscription is. There is already a number of things that are completed. One is still ongoing. That is the SQL server was spun up, but the database is still being created. So in a moment, we will essentially see what happens here. But you get the picture. This is mine. It's my Azure subscription. It's not somebody else's. I own the data, and I can do with it whatever I want. So if I look now into my Project Hogada website after it has been spun up, the one that I just spun up will be quite boring because I just created this. There's nothing to report, and there's nothing to see. So I go into one where the team that has been working on this project has been tracking for a while, myself also. I am here listed as bus number 88, and when we zoom out and we go a little bit over to this side, there we see there's two buses actually that are now in Seattle, bus number 88 and bus number 99. This is Ahmed, the leader of the team. He's over there and making sure that I'm not telling any nonsense about the application. So once we are there, we can register new phones and the devices that we are tracking. So at that point, there is a client-side application, one that we also make available through HockeyUp and through GitHub as an open source application. It's powered by Apache Cordova and implemented as a Ionic application, and that means you can run it on Android, on iOS, and on Windows Phone equally. Once you open this application and install it, it wants to configure a backend, and this is what you can do here. So there's a barcode reader that essentially takes the URLs of the backend and your environment that you just have spun up, and it configures your client application accordingly. Very simple. No development required to do this. And then we can start tracking our applications away. We can put up something like geofences here, and you see here there's geofences that are created around the Washington State Convention Center. And these geofences, they are editable. I can create new ones, of course, through this interface. And if we look at the WSCC, you see there's two buses. When either one of those, that is Ahmed or myself, arrive here, we will send a notification. And if Ahmed goes home before his boost duty is over, we get a notification about that one as well. And we have immediately documented he left the room. So on the client, this application runs in the background, but obviously, this application now we have set it up. You can switch it on and off as you like. So automatically it starts when you reboot the device, but you can switch the tracking off. So along with that, there is a number of reporting components that come to play. So we have the number of trips that we have in here, the total trip duration, the mileage that we had per trip, the average trip mileage, and the total trip mileage. That could be interesting when you think about something like charging your customer for travel cost, for example, per mile that you had to do for the delivery. Or if you are thinking about tax deduction, how many miles did you do on business trips, right? Then if you have this application running just while you're doing your business trips, we get these numbers as well. So that's not quite all of it. Project Hogada also deploys a set of APIs. Everything that we do here in the user interface is not just a hard-coded access to the backend. There is a set of APIs and functions. Oh, apropos functions, the Azure functions, they do some interesting things like trip detection, as I mentioned. If you have a device that is connected to your bus, you can easily determine when you switch on the ignition key or switch it off, when the trip ends or starts or ends. If you have a mobile phone, that is not quite as trivial. So what we have done here is we have a trip detection, and I can filter down. Let me demonstrate this on one day. And if we look at bus number 88, and here's the number of trips that I can select. If I select one of these trips, then I can drill in and I get more information about the start and the end, the speed that I had, and so on. All this information is conserved in this trip. So let's pick this one. If I go into any of these locations, you see what the speed was, what the accuracy of the GPS was, and so on. So I get all these metadata. But the most important thing is I get the start and the end so that I can determine what the mileage on that particular trip was for the purpose that I mentioned before. So that was Azure Functions. But around that, there's also APIs. And these APIs, they allow me to do with it whatever I want. So I can build application and I can integrate it into Office, Excel, a CRM system. I can put it into a bot, and I can load the bot and connect it to things like Skype, Teams, Slack, Cortana, and whatever else you can think of how you want to interact with this information. So here we have a bot that I have built that does things, many different things. Tells me about flood risk areas. It tells me about things like the value of a parcel. It can tell me about wildfires and so on that I grab and basically process to the backend and surface in this bot. One of the things that it does is it can tell me where my assets are. So if I go in here with Skype or with Teams or with Cortana, and I ask where is bus 99, then the bot starts on chatting and it tells me these are the coordinates. Then it calls into the Bing Maps reverse geocoder and it describes where the last known location of this asset was, and that was apparently on the I-5 when we basically lost the GPS signal or got the last signal from bus 99, that is Ahmed, but I know he's here. In this case, as soon as you get somewhere into the garage, you don't have a GPS signal anymore. It basically takes the last known location of that. Well, so that is one of the interesting new thoughts that we have around having quick start solutions ready for you in a way that you can use them as a simple turnkey solution if you want to demonstrate something, or have a simple team tracking solution as what I showed you here, or for smaller companies, small and medium businesses that have a limited number of assets. We are thinking about improving this in many ways, how we can integrate some of our larger and newer APIs in there. The truck routing, for example, right? Some of these time-based searches in there. And there's a few improvements that we want to make before we put everything open source onto GitHub, but that is the plan. We make all of this available open source. The interest that we have is to basically show how a solution using Bing Maps and using our APIs can look like, and it may be good enough for many of you or some of you, but if you want to change it, then we want to give you the opportunity as well. If you want to check in and improve it, we want to give you the opportunity as well. We make it open source on GitHub and want to share it with you. So now we're pretty much at the end of my time. I want to leave a few minutes for questions and answers as well. But ultimately, I have shown you 8 new features, APIs, and a quick start solution together. The custom map styles, I've shown you the bird's eye images in the version 8 control, and I've shown you this GeoXML module, which is coming shortly. Then the 4 new APIs for truck routing, isochrones, distance matrix, and the proximity scoring. And then finally, I gave you a quick run through Project Hogada, which is a quick start solution for vehicle tracking, which we will make open source. This is an interesting part, a few thoughts, new APIs that we bring out today, and we will improve on that for these vertical solutions and more advanced business solutions that go beyond standard mapping. But ultimately, this is one thing that we're excited about, bringing out these new APIs, making it available so that it infuses location intelligence into these learning machines, and the artificial intelligence all together is another interesting thing that keeps us excited and keeps us going, right? So there's no end and no new, not a shortage of new challenges for the geospatial technology and industry. If you have Cortana or the agent of your choice tell you that it is time to leave for the attendee party, then this is because it hits our APIs, and it tells you, considering the current traffic situation, it will take you around 20 minutes to get to the CenturyLink field. And there is so much more beyond the digital assistant that we can tackle in the future. It doesn't matter where we are looking. Computer vision on the images that helps us identify things like harvest forecast. If we think about certain business intelligence scenarios where you want to count certain objects on aerial or satellite images, there are interesting challenges around these artificial intelligence and geospatial technologies. If you think about something like mixed realities, there's a spatial component to that. And if you think about autonomous vehicles, they will not exist without a geospatial understanding of the world around them. And that is why we're so excited to keep going and crank out new APIs and work on new magic and infuse the technology with more and more intelligence as we progress. With that, I want to thank you that you was here so long at this late time and held out before the attendee party started. I want to encourage you to check out on the Cognitive Labs, labs.cognitive.microsoft.com, the new APIs that we launched today. Give us feedback. Tell us what else we should do and how we can improve this API or do something completely new. And we are here at the booth tomorrow again, not today anymore, but tomorrow we will be back on the booth and are ready to answer any questions you might have. And then there's perhaps a few interesting other sessions that I would recommend. You may have seen that from other sessions as well. There's a few tech talks. The one that you see here, 60/30, that is a shorter version of what I'm doing today. Then there is an interesting one on Cortana user knowledge to personalize the Cortana skills. That is something that I would recommend to sneak in if you think about these agents and a different way of interacting with these technologies. The language understanding and intelligence service, that is one of these cognitive APIs. I used it in the bot as well, so that it knows when I say, where is bus 99 right now, that it has to call this particular API and look for the entity that is called bus 99. That's a very interesting session as well. And then if you are more into neural networks, then maybe you want to look at Cognitive Toolkit. Great choice, and the bot framework, that was the one that I used here for my bot as well. So, we appreciate your feedback on the APIs, but we also appreciate the feedback on how we have done today. Then I hope that I see many of you at the attendee party later on. And again, I thank you for being here and thank you for taking the time. If you have any more questions, we have a few minutes left, 2 on the clock, and then as many as you want here in front of it. But if you have questions, please shoot.